Okay, so today we are going to start going one step further with our equations, and we're going to solve multi-step equations. So the biggest difference between what we are doing now and what we were doing last week is that before we start, and we've done some work on this, our step one is going to be to simplify both sides of the equation. Our step two is something we're going to not be doing today, but it's going to be listed in our steps because we just want to make sure. And we will work on, hey, what if this isn't true next week? But our step two is we're going to make sure the variables are all on one side of the equation. And so I'll put a little star by that because we're not going to be doing this today. All of our variables are already going to be on one side of the equation. Step three, really now, once that happens, we should be in the same position we were before, where it's going to be a two-step equation. And so remember, we're going to undo the last operation. So thinking of order of operations, we're going to undo the last operation that was done. And I'll show you what I mean by that when we do an example. And then finally, step four, what we'll have left is a one-step equation. So we'll undo order of operations again by solving the one-step equation. So once we get to that spot, it's going to be helpful maybe if you have a highlighter or a different color, or even if you don't, you can circle where the variables are. So let's take a look at our first example here at the top. We have m plus 2m minus 4 equals 14. And we see that we're going to simplify both sides of the equation. So the only thing to simplify are adding these like terms, and if it helps you to put a 1m in front of that, do that. So 1m plus 2m, this becomes 3m minus 4 equals 14. And so sometimes it's helpful for us just to kind of identify, hey, this is my variable. That's what I'm trying to get alone. So we know what thing to do next. So I'm going to hop over step two. We already have my variables together on this side. I'm going to undo the last operation that was done. So thinking order of operation, PEMDAS, the last operation that's done is the subtract 4. So I'm going to undo subtract 4 by adding 4 to both sides of the equation. Remember, we want to make sure that we have a line on that equal sign, so we're identifying what the sides of the equation are. So I've undone the minus 4 by adding 4. What I have left now is 3m equals 14 plus 4, or 18. So now our final step 3, it's a one-step equation. This means 3 times m equals 18. And we're going to undo 3 times m by dividing by 3. We get m equals 6. So as you're showing your work, now as we're starting to get more complicated expressions, make sure that you're showing me on your problems that you're identifying the two sides of the equation and that you're showing me the operations to both sides to keep it balanced. And if you would like to go back and check, we put our m back into our original expression. Does 6 plus 2 times 6 minus 4 equal 14? So this is my check. 6 plus 12 minus 4. So 6 plus 12 is 18. 18 minus 4 is 14. So that does check out. Let's do a second example so we can see simplifying with the distributive property. So when I do step 1 on this equation, simplifying both sides, I would need to get rid of this parentheses, and the way I do that is I take -3 and I multiply by everything inside. I like to write that out. -3 times m minus 3 times 6. I wrote minus there because of this minus. And actually, my mistake, this should be a -3 times 6. I don't want to overcomplicate this. I just want you to realize you can think of it as minus a -3 times 6. Or just realize a -3, you could call it a -6 if you want. So if you'd prefer to think of this as plus a -6, that is also good. Either way, a negative times a negative is going to make that a positive. So we have -3m plus, so make sure we're real careful on this. This is now plus 18 equals 4. All right, so now that I have simplified by removing the parentheses, I am going to undo the last operation that was done. The last operation that was done was the plus 18. So I'm going to go ahead and subtract 18 from both sides. So we have -3m now. This is 0. We undid that. And 4 minus 18 is a -12. So I undo, or I solve the one-step equation by dividing both sides by a -3, because this means -3 times m. And m is going to equal -12 divided by -3, which is a positive 4. Again, going back and checking if you would put 4 in here. 4 plus a -6 is a yeah, 4 minus 6 is a -2. -3 times -2, that would work out. Actually, you should Jolly Rancher me because that doesn't work out. I made a mistake. 4 minus 18 here, see, this is why we should be in class, because somebody would have told me this, is not -12, it's -14. And -14 divided by -3 is actually 4 2/3. Okay, let's do one more example without me making mistakes, so you can see how that works. Third and last example for today, we're going to simplify both sides of the equation. What we have here is both a parentheses and another x. So we are going to get rid of that parentheses first by using the distributive property. So I have 3 times x plus 3 times 12. On this side, I still have minus x. I'm going to go ahead and remind myself that that's the same as minus 1x equals 8. I still have some simplification to do because I have a 3x minus 1x on this side. So I need to add those like terms. 3x minus 1x is 2x plus 3 times 12 is 36. If you would rather write it as 36 plus 2x, that's fine. It's going to just make sure on this side I have a 36, a plus a 2x on the one side of the equation, and that equals 8. All right, so my equal sign is right here. I'm going to undo the last step. I'm going to subtract 36 from both sides. I'm going to continue up here. I have left now on that side 2x equals 8 minus 36. And 8 minus 36 is a negative 28. So finally, I'm going to solve the one-step equation. I divide both sides by 2. And I'm left with x equals a negative 14. And so then, once again, if you would go back and check that in here, you would get that that equation does indeed work. So we're going to be continuing to work on this the entire week, but there's 3 examples, and I'll give you a few problems to practice.